Now we are going to explain the last item in this chapter, which talks about friction. Friction. Now, whenever you have a block on the ground, a table, and I try to pull it by a force. I pulled it by a force. I pulled it by a force of 10 Newton, and the body did not move. What is the reason? The reason is there is friction. But there is a friction force of 10 Newton. I pulled it by a force of 20. And still the block did not move. This means the frictional force became 20. I pulled it with a force of 30, and the block did not move. This means there's a friction of 30. When I pulled it by a force of 40 Newton, the body started to move. What is the meaning of this? The meaning of this is that frictional force can have any value up to a maximum value. The frictional force will increase as the force causing the motion increase, the friction increase. The friction force keep increasing until it reaches a value which cannot go beyond. What do we call that value? Maximum frictional force, limiting friction. But there is a maximum frictional force called limiting friction. Limiting friction. On what factors depend this limiting frictional force? It depends on two factors. One is the condition of the surfaces. And if I repeated the experiment before, which I have done, and this time I had my block, I made its surface very rough, and the table was very rough, then the frictional force will increase. If I made the bottom of the surface smooth, and the table also say a smoother surface, then the frictional force will decrease. But the frictional force will depend on the nature of the two surfaces. We have to give this a factor. Now, frictional force also depend on the push between the body and the plane. Not always this push between the body and the surface equal to the weight, because maybe there is an additional force on the top of the body which increasing its push on the surface, an additional force making the push on the surface harder. What will increase if I make the push on the surface harder? The normal reaction. And therefore we say the frictional force will depend on the normal reaction, R. The frictional force will be a fraction of this normal reaction. The frictional force could be 1/3 normal reaction, could be 1/4, could be half. What do we call that fraction? We are going to call that fraction coefficient of friction. And accordingly, we say this in what we call the limiting frictional force. The limiting frictional force equal mu times R. This mu is what we call coefficient of friction. We call it coefficient of friction. It is how much of the normal reaction will become the frictional force. This value of mu could be 0.2, 0.3, 0.5, 0.6. Therefore, we have a limiting frictional force will depend on R and mu. What is the meaning this limiting frictional force? It is the frictional force which would be the maximum one which we can have. And if you try to pull a body by a force less than the limiting friction, then the friction will not reach the limiting friction. If I pull with 10 Newton, it is not yet limiting friction. 20 is not yet 20 limiting friction. 30 was not the limit, but 40 was above the limiting friction. That's why the body will move. Therefore, we say this. If any body in a surface or a body in a surface, which I know how much is the normal reaction. The important thing is the normal reaction. I would calculate a value for the maximum friction, the maximum frictional force equal mu R. Mu will be given to us. If I pull with a force less than this value, then the friction will be just equal to what I pull with it. Let us have this with numbers. For example, I have a block in a horizontal surface. The block weight is 10 kilograms. The weight is 10 G. In this case, this example, there was no other forces. There's no normal reaction and the horizontal force P. Okay, given that one in this problem R equal 10 G, which is 98 Newton. It was given that mu equal 0.5. Therefore, the maximum frictional force is 0.5 times 98, 49 Newton. If P equal 10, then the frictional force equal 10, and the body at rest. If P equal 20, then F equal 20 at rest. If P equal 30, then friction is 30 and the body at rest. If P equal 40, F equal 40 and the body at rest. But if P equal 49, friction is 49 and the body at rest or just about to move. But it's P but if P is 50 Newton, then the friction stops at 49. Therefore, P minus F equal MA, 50 minus 49 equal mass times acceleration. We take another example, right? A force inclined at an angle now, as it is given here, right? A force, by this example, it says a box of 10 kilogram rests in limiting equilibrium on a rough plane inclined at 20 degrees. If a plane inclined at 20 degrees and the block is there, the weight of the block is the mass 10 by 10 g, the weight. The normal reaction are there, right? Now it says here, and there's no other force was, as the question say, that it rests in limiting equilibrium, means the body want to move down, prevent it from moving down by the friction, and the friction is limiting, means F equal mu r. Now resolving the 10g, we have here 10g cosine 30, and we have here 10g sine 30. If r equal 10g cosine 30 and F equal 10g sine 30, because the body is in limiting equilibrium. If a body is in limiting equilibrium, then F equal mu r. From there, we can get the value of mu. We have F and we have R, we can find mu. Another example. We have a block in an inclined plane. Now we have a block, right? Now the question says a block in an inclined plane, the block 10 kilogram. Say a horizontal force is acting on the block. Given that the block is equilibrium, find the maximum possible value of F. Now, it said here there is a horizontal force act. It's saying the question, a horizontal force act on the block, so we extended this side. A horizontal force P. And the angle of the plane, right, is 20. This angle is 20. The mass of the block is 10 kilogram. The weight is 10 g, and the normal reaction R. We resolve the weight, 10 g cosine 20, and this one is 10 g sine 20. And this is a force P cosine 20 and P sine 20. It's saying the question that horizontal force is applied, find the value of the remains in equilibrium, find the maximum possible value of P. When it's because it says the maximum P means the block is about to move up. So the frictional force is down the plane. And the frictional force is F, is down the plane. We get the value of R equal 10g cosine 20 plus P sine 20. And we can get the value resolving along the plane, that P cosine 20 equal 10g sine 20 plus F. And we have the equation F equal mu R. Mu obtained from the first part of the question. So we substitute F, which is P cosine 20 minus 10g sine 20 equal mu times open factor R. What is R? 10g cosine 20 plus P sine 20. Therefore, we got P cosine 20 minus mu P sine 20 equal 10g sine 20 plus mu times 10g cosine 20. We take P common factor, cosine 20 minus mu sine 20 equal 10g equal right hand side. This is here. From the equation we can find the value of P. You can get the value of P. P equal, right, the ratio of two things. Now, P would be equal to, right, mu, we got the value of mu 0.36, okay, therefore it is 3, we got mu from the previous part, it is 0.36. So we got 3.6 G cosine 20 plus 10G sine 20 over cosine 20 minus 0.36 sine 20, from which we get the value of P equal 82 Newton. Another question, we have an inclined plane, and there's a block on the plane, right, and we are asked to find the value, there's a force P, okay, of 100 Newton, now there's a value of P of 100 Newton. The weight of the body, the block weight, is 10 kilogram. It is 10 kilogram, the block weight, 10 kilogram. Therefore, the weight is 10G. The angle says 30 degrees. There is a reaction R, and we're given that mu equal 0.5. And we're asked to find the acceleration up the plane. Now the body move up the plane, this means friction is down. We resolve the weight 10G cosine 30. And this one is 10G sine 30. We get the value of R equal 10G cosine 30. We are given the coefficient of friction, يبقى F equal mu R. يبقى 0.5 times 10G cosine 30 equal 5G cosine 30. We say 100 minus friction minus 10g sine 30 equal MA 10A. 100 minus 49 cosine 30 minus 10g cosine 30 is 98. 49 means equal 10A. Right? Now, we calculate 100 minus 49 cosine 30 is calculator, and we do 49 cosine 30 we got 42. We add to this 49, so we get 100 minus 91.43 equal 10A. From this, we get the acceleration A equal to we'll find the acceleration A equal to 0.86. Now, we covered now the topic of the last topic of the chapter, which is friction. And now we learned that if the body is already moving, that means that if the body already moves, that means we reach the limiting friction. If the body about to move, we also reach the limiting friction. But when do we have limiting friction? In two cases: if the body is about to move, or if the body is already moving. This is the end of the chapter.